us to look how they set the first part of your trigonometry in the examinations. Remember the background that we've just had. It is all you need to solve any problem. This was in November 2008. It was question 5. It says, remember one thing only. Think of the definitions, which are referred to as SOHCAHTOA. Think of the quotient identity, which is sine theta over cos theta is the same as tan theta. Think of the special angles. Think of reduction formulae. Think of the double angles and the compound angles. That is going to assist us. Remember, in your Cartesian plane, we have got 0, 90, 180, 270, and 360. And you know which quadrant is this. It's either theta or 90 minus theta, and so on and so forth. So when we see in our Cartesian plane, we start from 0, move right around to 360. So it is advisable that for you to see the quadrant, if you've got big angle, change it into you can't see exactly which quadrant is this. But when you talk of 170, we know that it's in this quadrant. When you talk of 100, we know that it will be in this quadrant. So it is important that you must identify the quadrant first, and you must know how to deal with that quadrant. Remember, this one is 90 degrees plus theta, this one is 180 minus theta, this one is 180 plus theta, and so on and so forth. That will be 360 minus. And I know that all students take commerce. That this denotes that all ratios are positive here. Only sine is positive in the second quadrant. In the third quadrant, only tan is positive. In the fourth quadrant, only cosine is positive. Now, when I look at this problem, I always advise young learners that you must brush it off first to check what are the difficult parts on that or things that you need to change. I don't know which quadrant is this, so I need to deal with that. Number 2, 300. Do I know 300 is in which quadrant? This is 270, so 300 is here. I can either call this quadrant 360 degrees minus theta or 270 degrees plus theta. Remember, you always try and avoid 90 and 270 because it changes ratio and you might make mistakes. But at times you'll be forced to go to them. I know this quadrant. I know cos 14. Remember the question will say, prove that this is equal to that side without using a calculator. When they say without using a calculator, surely I will be using special angles. Now, when they give me 14, the angle which is 14 degrees, I will never be able to find this without using a calculator because it's not a special angle. Now, what is this telling me? You must have another cos 14 below so that it will cancel out. I put that at the back of my mind. I see another problem. I see negative angles. I'm not used to negative angles. This means I'm going this direction, 135 degrees. So it is advisable that I make all my angles positive and make all my angles between 0 and 360. How do I do that? Remember, if I've got an angle like this one, 30 degrees, if I add 360 degrees in this angle, I will end up on the same position. Or if I subtract 360 going back this way, if I subtract 360, I will end up on the same position. What is this saying to me? Adding 360 does not change the position of the angle. Or subtracting 360 will not change the position of the angle. So if I have an angle above 360, I can subtract 360 in that angle. It will not change the position of that angle. In this particular case, if you've got big angles, which are bigger than 360, subtract 360 to them. It will not change the value of that particular angle or the position of that angle. If we subtract 360 from 480, I see a 120. Now I know which quadrant is 120. 120 is here on the second quadrant. And I can refer to this as 180 minus or 90 plus, the second quadrant. No, I know exactly now the quadrant. Another problem here is this minus 135. How can I make this a positive angle? Whenever you see a negative angle, just add 360 to it. If you add 360 to minus 135, it will be 225. This 225 has been hidden here, 225. Do I know where is 225? Yes, I know where is 225. It is somewhere here, 225. It is in the third quadrant. Remember, I'm dealing with sine there. Let's look at my denominator. I see a 104. I know the quadrant where is 104. It is in the second quadrant. Do I know this quadrant 225? Yes, 225. It is in the third quadrant where tan is positive. So I know exactly where these angles are. Remember, I'm taking the left-hand side. I'm taking the left-hand side and I'm proving that this is equal to 3 over 2. Now I know that tan is 120 degrees, and I know where is 120 degrees. It is in this quadrant. Remember, I do this in conjunction with special angles, because it says do this without using a calculator. So when I say 180 minus, what I'm subtracting must be a special angle for me to be able to solve it. 180 plus, what is this plus? It must be a special angle, and so on and so forth. Let's do this thing and see if we do get these special angles. We now know that tan for 8, we've changed it, we've reduced it, reduction. We've reduced it into 120, but we must reduce it such that it is a special angle. Let's see if we can do that. So we've got tan into, this is 120. 120 is the same as 180. Remember, it is the second quadrant. 120 is the second quadrant. You can call it 180 minus or 90 plus. Let's do this thing. It's going to be 180 minus what will give me 120? 180 minus 60, yes. That's a special angle. That's what I wanted to get. Let's move on to 300. This is times sine 300. 300 is in which quadrant? It is in this quadrant. How do we refer to this quadrant? It's 360 minus. Is that going to give me special angles? Let's check it. 300 is the same as 360 minus what? Minus 60 degrees. Here comes another special angle. It is 60 degrees. I can do that without using a calculator. Cosine 14, I don't know what that is. I don't stress about it. This is the same as 225. 225 is in which quadrant? It is in this quadrant. How do we get 225? It should be 180 minus 45. Yes, I do get a special angle there. This is the same as sine into 180 degrees plus 45 degrees. Let's look at the denominator. Let's remember one thing. I don't work like a donkey. This is 225. How did I change 225? 180 plus 45. What is this angle? It is 225. It has cut and paste. It's the same thing as that one. So I don't have to think again. So when I've got cos 225, it is the same as 180 degrees plus 45. So it is important that you do this with your eyes open. Now, I remember at the back of my mind that I had cos 14 and I need to deal with this cos 14. So if I can get cos 14 below, those two will divide each other. Let's work it out. I have sine 104. 104 is in the second quadrant. How do I get this in that? Okay. If I have sine, I want to get cos. How do I change sine into cos? I've got to introduce 90 degrees. So that's my starting point. So this is the same as sine into 90. To get 104, it should be 90 plus what? 90 plus 14. 90 plus 14. There comes my 14 now. I can see how it's going to go away. Remember, at the end of the day, we want to get 3 over 2. Let's move on. Reduction. You start with their brackets. 180 minus. Which quadrant is 180 minus? It is the second quadrant. How is tan on the second quadrant? Remember, 180 minus on the sign is positive in that quadrant. So when we talk of 180 minus, it is the second quadrant. And how is tan on the second quadrant? It is negative. So what is going to be, how do I reduce this? It would be minus tan of 60 degrees. And 60 is a special angle. I can find it without using a calculator. 360 minus. If I've got 360 minus, it is this quadrant where cosine is positive. And what am I dealing with here? I'm dealing with sine. 360 minus, it is the fourth quadrant. And how is sine on the fourth quadrant? You ask yourself these questions. You talk with your question paper as you write. This is times. This 360 minus, fourth quadrant. How is sine on the fourth quadrant? It is negative. Because this is 360, it does not change the ratio. I will have sine of 60 degrees. Times cos 14, there's nothing I can do with it, times, let's look at this one. 180 plus. Which quadrant is 180 plus? It is the third quadrant. How is sine on the third quadrant? It is negative because only tan is positive on the third quadrant. It helps when you do trigonometry to have this diagram next to you so that you can interact with it all the time. So this then will be, where are we? We are still on the numerator. 180 plus, it is 180 plus is the third quadrant, and sine is negative there. Does not change the ratio, so this will be sine of 45 degrees. I've got special angles and this problem here of 14. This is all divided by, let's work this thing out. 90 plus, which quadrant is that? 90 plus, it is the second quadrant. How is sine on the second quadrant? It is positive, but now we've got 90. 90 will change the ratio. So what will be this one? It will be cos of 14. So the ratio was changed by this 90 degrees. Let's move on to this other one. 180 plus. Which quadrant is that? 180 plus? 180 plus. It is the third quadrant. How is cos on the third quadrant? 180 plus, we said it's the third quadrant. How is cosine on the third quadrant? It is negative, so it's times minus. Because this is 180, it will not change the ratio, it becomes cosine of 45 degrees. Remember what we said earlier on? We said sine 20 is the same as cosine of 70. When I add these two, I get 90. Sine 50 is the same as cosine of 50 or 40, because when I add these two, I get 90. In the very same way, sine 45 degrees will be the same as cosine 45 degrees. It helps to understand these things. When you operate, it makes your life easier. Let's do this thing. I want us, because we are multiplying, it makes our life easier. We can say cos 14 divides here once. Let's start with signs. I can see that my answer there must be a positive value. So what is negative times negative? It is positive. Positive times negative, it is negative. Negative divided by negative, it is positive. Yes, we've got a positive answer. Did we expect a positive answer? Yes, we did. Right, let's move on. I know that from this information, sine 45 is the same as cosine 45. So this sine 45 goes in here, which gives us 1. So we're left with what here? Tan 60. And what? And sine 60. Remember your diagrams. If I've got this diagram here, which you are not given in the exam, you must have it. If I've got 60 here, what do I have here? I've got 30 degrees. Remember, this is root 3, right? The bigger one is 2, the smaller one is 1. That's how I remember this one. Do I have 45 here? Do I have 45? It's gone. I've got 60s. Let's use these diagrams to solve this problem. Tan 60. Opposite over adjacent. So tan 60 is the same as root 3 over 1. That is tan 60. What then is sine 60? Remember your definition, so it's opposite over hypotenuse. So we are looking for 60. So sine 60 will be opposite over hypotenuse. This side is opposite, this one is opposite, this one is opposite, this one is hypotenuse, this one is adjacent. So when you talk of sine 60, so it's opposite over hypotenuse, so opposite over hypotenuse. So this will be times. Opposite is root 3 over hypotenuse, which is 2 in this case. So when you work this thing out, let's work it out. What is, without using a calculator, what is root 3 times root 3? It is 3. What is 1 times 2? It is 2. This is exactly what we are required to find. The left-hand side is, of course, equals to the right-hand side. Right, I want us to continue with our problem solving our problems in trigonometry. And remember the basics that we started with, they becomes very important. In this particular case, prove that the left-hand side is equal to the right-hand side without using a calculator. We've got cos 75 equals to root of 2 into root 3 minus 1 all over 4. Stuck. How do I go about doing this? I see the left-hand side, I see the right-hand side. Anything familiar? I know root 2 and root 3 from my special angles. I've seen those in the special angles. Maybe that's the thinking pattern that I have. If I've got 75 Can I make these special angles? Yes, I can make these special angles. I'm taking the left-hand side. If I've got cos 75, it is the same as cos what? I change this into special angles because I see the root 2s and root 3s there. This will be 30. 30 plus what will give me 75? 30 degrees plus 45. Yes, this is 75. I'm getting into special angles now. Cos 75 is the same as cos into 30 plus 45. Once I write it in this form, another subtopic crops up, which are compound angles. Sine cos into A plus B. What is the rhythm for cos? It is cos, cos, change sign, sine, sine. Remember those rhythms. If it is sine, it will be sine, cos, cos, sine. If it is cos, it will be cos, cos, change sign, sine, sine. Let's do just that. So this becomes cos 30, cos 45. It's cos, cos, change sign because it's C. C start with C, cos start with C and change start with C. So it's plus there, it should be minus here. Remember the rhythm, cos, cos, sine, sine. Sine 30, sine 45. That's why we started with those compound angles. That's how you go about spreading it. Now it's become easy, it's compound angles. I brushed off first. There are things that I know. Sine 30 is not, cos 45 is the same as sine 45. So whatever I get here, I'll cut and paste it there because it is the same thing. 45 and 45, it's 90 cofunctions. This will assist me. Let's do this thing. If you want to go to your diagrams, but you can use the calculator in the exams, they won't even know it. 30, 60. The other one, I got 45, 45. Right, this comes in handy. Where there's 3, I put root 3. The bigger one there, the smaller one here. 1, 1, and root 2. These are my diagrams. They come in handy. When you do this without using a calculator, it simply means use these diagrams. Let's go. Cos 30. What is cos 30? This is where 30 degrees. And cosine, the definitions are important. Ka, adjacent over hypotenuse. So cosine of 30 is root 3 over 2. This is the same as root 3 over 2. Ka, adjacent over hypotenuse. Cos 45. This is where 45 is. Ka, adjacent over hypotenuse. Ka, adjacent over hypotenuse. Even if I use this one, adjacent over hypotenuse, which is adjacent is what? Ka, adjacent over hypotenuse. 1 over root 2. 1 over root 2. Remember, this is the same as, let me just work it out here. If I've got 1 over root 2 times root 2 over root 2, this will be, this is root 2 over 2. So it is the same as this one. You can put it in that form or in this form. So for us to be able to work it, let's rationalize the denominator in this particular case. So we'll have root 2 over 2 in this way. So even when you go to your calculator, you'll find the root 2 over 2. Root 2 over 2, which is this one. Remember, it was 1 over root 2. We'll rationalize the denominator. This is what we get. That's 45. Remember that cos 45 is the same as sine 45. So I know exactly what to put in there. Minus sine 30. Sine 30, this is where 30 is. Definition for sine. So opposite over hypotenuse. Sine 30 is 1 over 2. Minus 1 over 2, which is our half, times cos 45, times sine 45, which is the same as cos 45. I don't have to redo it. Right, this is what we have. Remember, this is what we want to get at the end of the day. This is where we want to go. I can see 4, I can see 4 here. So this is equals to. Right, this is where you need to work smartly. Remember what you want to get at the end of the day. I don't lose sight of what I want to get. I've got root 3 into I've got root 2 into root 3 minus 1 all over 4. I can see the all over 4 between these two. If I multiply these two, I've got 4 minus. I can see 4 here. Makes life easier. 4 is starting to show up now. Let's look at this one. Root 3 times root 2, what do I get there? I got root 6. But there's nothing wrong in writing root 6, but it's not smart. It will be smarter to write it in the form that is in there. So I'll rather keep root 3 times root 2 in this form, because I've got that in that form. There's nothing wrong in writing root 6, but it's not that smart. Let's go over to the other side. This times that, I've got root 2 over 4. All right, let's work it out. Let's go back to grade 8. Adding and subtraction of fractions. What do? You find the LCD. In this case, it is 4. There comes that 4, okay. 4 into 4 goes once, times that, it is root 3 times root 2, minus 4 into this goes once, times that, it is root 2. That's what we have. Your eyes are the most powerful tool in your mathematics. Your eyes are the most powerful tool in your mathematics. Look at the numerator. What do you notice in the numerator? How many terms do we have in the numerator? 2 terms, separated by plus or minus sign. It's this term and this term. What do you see in this term, which is also there in the other term? We call it a common factor. You take it out. If I take out root 2 here, what will I be left with? If I take this one out, I'll be left with a root 3 minus. This times what? Times 1 will give me that one. This is all over 4. It is exactly what we wanted to get. So it is true that cos 75 is equal to that one. Therefore, the left-hand side is equal to the right-hand side. Remember of the basics that we started on. It will assist us to go a long way in trigonometry. Thank you.